Hi everyone, welcome back. So we're going to continue this short series on polynomials, and we're going to have a look at what we can do with them in terms of arithmetic. Okay, so by arithmetic, I mean that we can do the following things to two or more polynomials. Okay, so we can add them together, we can subtract one from the other, we can multiply two polynomials together, and we can also multiply the polynomial by a constant. Okay, that is, multiply it by just a number or a pronumeral of some kind. Okay, we're not talking about division here. Division requires its own whole explanation. Okay, so we're not going to look at division in this video. We're just going to briefly touch on how we can add, subtract, and multiply polynomials together. All right, and in each of these examples, we're going to be using two polynomials. But the same process would work for 3 polynomials or 4 or 5. You're not going to get that complicated. The most complicated you probably get was 3 polynomials, and the polynomials themselves are going to be pretty simple. Okay, so most of the time you're just going to be working with 2 polynomials. It's very rare that you get anything above 3. Okay, so we're going to add them together. So we've got these two polynomials, p and q, and we want to add them together. Okay. Now the way that you add polynomials together is you add them like term with like term. That is, you add terms which have the same variables, and the variables have to have the same powers. Okay. So if we look at p, let's just write it out. So we've got p of x. We're going to write it as x to the power of 3 minus 6x plus 3, and we're going to add q of x. Now when I say add q of x, I mean add each of these. So add this one, add this one, add this one. Okay, and we're going to contrast this when we do subtraction, and we're going to make it so you don't get confused. Okay, so we're going to add x squared. We're going to add negative 3x, which is just, you can just write minus 3x, and we're going to add positive 1, which you can just write as plus 1. Then all you've got to do is collect like terms. So are there any more x cubed terms around? No, so you just leave it as x cubed. Are there any x terms around? So we've got minus 6x. Yes, there's one over here, minus 3x. So we've got negative 6x minus 3x. That's minus 9x. Okay. Do I have any constant terms around? I've got positive 3, I've got plus 1, so 3 plus 1 gives you 4. And I've basically done everything except for this plus x squared. So we can write plus x squared there. And if you want, which I like to do, is write it in descending order of powers of x. So I'll do x to the power of 3 first, plus x squared minus 9x plus 4. Okay, and you could do that in the second step. There's no reason why you have to do them in the order that they just show up from left to right. If you know what you're doing, you can just write them in order straight away. Okay, but that's it. That's how you add polynomials together. Okay, term by term, you just add like terms together, and that's it. Okay, let's do some subtraction. So we've got the same polynomials as in the previous question, and we're going to do the two different subtractions. We're going to do p minus q, and then we're going to do q minus p. Okay, and the order that you subtract makes a difference. Okay, it's not necessarily the case that p minus q will turn out to be the same as q minus p. In fact, that's very rare for that to happen with anything that you do, unless you subtract the same thing from itself. Okay, you'll always get something different. So again, you can just write it out, x cubed minus 6x plus 3. Now, because we're subtracting q of x, that means we're subtracting that term, we're subtracting that term, and we're subtracting that term. Okay, so if I write that out, I say I'm subtracting x squared, I'm subtracting negative 3x. Now, if you subtract a negative, it turns into positive, so you're really adding 3x. And then I'm subtracting positive 1, so I write minus 1. Okay, so just be really careful with that. When you subtract an entire expression, you're really subtracting each term individually. Okay, So the minus doesn't just apply to the first term in that expression, it applies to every single term in that expression, okay? Anyway, back to this. So we've got x cubed. I'll just do it all in one step. So x cubed, there's no other x cubes around. Let's go down one power. So x squared, are there any x squareds around? Yes, minus x squared. All right, there's no other x squareds around. Okay, what about just x? Okay, well, I've got minus 6x plus 3x. I'll cross them off as I go along. So minus 6x plus 3x, that gives you minus 3x. And I've got plus 3 minus 1, it gives me plus 2. Okay, let's see what we get when we do it the other way around. So we'll do q of x first. So x squared minus 3x plus 1. And we're subtracting p of x, which means we're subtracting each of these individually. So we subtract x cubed, we subtract negative 6x, so that turns into plus 6x, and we subtract 3. Okay, let's do this all at once. So I'm going to write them again in decreasing powers of x. So we look for the cubed first. There's minus x cubed here. So write minus x cubed. That's it for the cubes. What about the squares? Well, we've got x squared there, so it's plus x squared. That's it for the squareds. What about just x? So I've got minus 3x plus 6x. That gives me plus 3x. And I've got 1 minus 3 gives me minus 2. Now look at the difference between p minus q and q minus p. It's pretty much the same thing, except all the signs of our terms have flipped around. Okay, so that's gone from positive to negative. This one's gone from negative to positive. This one's gone from negative to positive, and that one's gone from positive to negative. But the values themselves are still the same. Okay, and that's going to happen every time you swap the order of subtraction for two things. Okay, that's just what happens. Okay, so that's subtracting. Again, very similar to addition. You just do term by term, just making sure that you negate all the terms in the second polynomial when you add them onto your expression. Okay. All right, multiplying polynomials. So again, we've got the same two polynomials as previously. We're going to multiply them together. And the way that we do it is you just use the distributive property, just like you do when you expand binomials. Okay, so if you just do like, 2x plus 1 times 3x minus 2, you just go, okay, 2x times 3x, 2x times negative 2, 1 times 3x, 1 times negative 2. That's you using the distributive property. Okay, use the same thing when you multiply polynomials. Okay, so let's do that. So x cubed minus 6x plus 3 times x squared minus 3x plus 1. Okay, so let's start with x cubed and multiply each of the terms in the second polynomial by x cubed. So I'll go x cubed times x squared. Index laws, you add the powers and get x to the power of 5. And we do x cubed times negative 3x. It's minus 3x to the power of 4. X cubed times 1 is just x cubed. Then we move on to negative 6x. So negative 6x times x squared is minus 6x squared. Negative 6x times negative 3x. Oh, sorry, that should have been a cube. Negative 6x times negative 3x. Well, negative 6 times negative 3, positive 18. So plus 18x squared. Negative 6x times 1, minus 6x. And now we move on to our last term in the first polynomial, 3. So 3 times x squared is just 3x squared. 3 times minus 3x is minus 9x. And 3 times 1 is 3. So this can get a little bit tedious. That's why you don't really multiply more than two polynomials together, because it just takes so long. There is a shortcut if you're squaring or cubing or doing a single polynomial to the power of 4. In fact, not just any polynomial, but binomials, so two-term polynomials. We're not going to get into that, but there is a shortcut to do that. If you are interested, look into binomial expansion and Pascal's triangle. Okay, we might revisit that later once we do probability. Anyway, once you've multiplied everything out, then you just collect like terms, simplify, and write things down in the order that you like. So I'll go down by decreasing powers of x. So I'll start with x to the power of 5 because that seems to be the highest one. There's no other power of 5s, so that remains power of 5. Next, power of 4s. So we've got minus 3x to the 4 and nothing else. Okay, so that one stays as minus 3x to the power of 4. Cubes. So we've got minus 6x cubed plus 18x. No, that's not even a cube. Okay, so that's just minus 6x cubed. We don't really do anything else with that. I know I'm missing something somewhere. Yes, I just completely skipped over that term. X cubed minus 6x cubed. How could I have missed that? So that's 1 minus 6 is minus 5x cubed. So they're both gone. That's why it's a good idea to cross them off and just make sure you're concentrating when you do your work. All right, moving on. So 18x squared plus 3x squared gives you plus 21x squared. Minus 6x minus 9x gives you minus 15x. And finally, you just got that plus 3 hanging around, and we're done. Okay, so you can see it's a bit of work to multiply polynomials that have more than 2 terms. It takes a while. What I want you to do though, at the end of the video, pause it, do whatever you want, but I want you to verify that if we multiply them the other way around, that you get the same thing. Okay, so instead of p times q, just do q times p and just verify that you get the same answer. Okay. All right, moving on. Multiplying by a constant. Okay, so if we look at our same polynomials as before, look at the first one here. We've got negative 3 times p of x. Okay, so we're multiplying the polynomial p by negative 3. And what you do there is just multiply everything by negative 3. Each term you multiply by negative 3 because it's just like writing out negative 3 times x cubed minus 6x plus 3. Okay, and you know how to expand something like this. Okay, you just multiply each term by the thing that's at the front. So you get negative 3x cubed plus 18x minus 9. Okay, simple as that. For the next one, you've got 2k times q of x, and q of x is x squared minus 3x plus 1. Okay, so each term we're going to multiply by 2k. And so for the first one, we get 2kx squared minus 6kx plus 2k, and you're done. Okay, so fairly straightforward to multiply by a constant. That's it. We're going to stop there. Again, we're not going to cover division. That comes later on once we've sort of introduced ourselves to polynomials and how we can work with them. But for now you know how to add, subtract, and multiply polynomials together. So I'll stop there and see you next time.